guys. Okay, this time I'm gonna try to solve this medium level question. The reason why I want to solve this is that this has a lot of dislikes, but ta-da! This was really popular question somehow. So I'm gonna try to solve this. Let's start the timer. Exclusive time of functions. On a single-threaded CPU, we executed a program containing a function. Each function has a unique ID between 0 and n-1, containing n function. Function calls are stored in a call stack. When the function call starts, its ID is pushed onto the stack, and when the function call ends, its ID is popped off the stack. The function whose ID is at the top of the stack is the current function being executed. Okay, each time a function starts or ends, we write a log with that ID, whether it started or ended, and the timestamp. You're given a list of logs. Logs I, representing the ith log message formatted as a string, function ID, start and end, and timestamp. Okay, for example, 0 start 3 means a function call with ID 0 starting at the beginning of the timestamp 3, and 1 and 2 means that 1 and at the time of timestamp 2. Note that function can be called multiple times, possibly recursively. Okay. Function's exclusive time is the sum of execution time for all function calls in the program. If a function is called twice, one call executing for 2 time units, and another executing for 1 time unit, exclusive time is 2 plus 1 is 3. Okay, to the exclusive time of each function in an array, where the value at ith index represents the execution time for the function with ID I. The value at okay. So example, input n is 2. 2 means 0 and 1. Logs 0 start 0, 1 starts 2, 1 and 5, 0 and 6. So this is 2, 3, 4, 5. Okay. Oh, exclusive is this. Sum of execution time for all function call in the program. Twice, 1. So I have to remove this from this 0. Okay, example 2. So 0, 0. So it's like this, and then we have this, this, this. So it's like 0, 1, 1. Let's say that 0 is here. 1, and then 2, 3, 4, 5, 6, and 7, right? So here 0 start. So this is for 0, right? till 7, and then 0 star 2, then 0 star 2, this is 0 2, and then and 5, and then 0 star 6, and then 6 here. So this is 1 2 3 4, and then 5 6 7 8, right? Yeah. Another 0, so if I see just this, and then this is 3, and then so 1 2 0 1 2 3 5, and then 7, so 0 is 7 and 1 is 1. Okay, so n is this, log size is this function n, timestamp could be very long. Okay, so what I can do is that from here we have to find the matching one of this and this. And how? So when I see here, when I see this, I see this again. So we know that one is nested and then one end. So we can calculate this. So for example, we know that human knows this and this are the pair. So, and remember that this is a stack. So push stack here, push stack up this, and then push stack this, and then this is another, and then when we see this, we know that this must be popped. So we pop this, and then we calculate, and then when this calls, we push, and when this calls, we pop, and then we calculate. So inside here, we know the sum, right? And then it pops. So now we calculate this, and then we subtract this to calculate the exclusive time. And then the other case is something like this. So we push, and then we push, and then we pop, and then we push, and then we pop. Then we pop. And then let's say that somehow this is called again in here, and this is called again in here. In this case, what you need to do is push, push, and then push, and then pop. We calculate this, and then pop, calculate this, but there was something before me. So before me, so we need to subtract that, and then yeah, some concept like before me. I mean, child time is necessary. So when something is popped, you can calculate child time, and then when something is popped, if child time is there, we subtract that. And child time belongs to this. This time belongs to this. So we start, when you start, we have to keep the child time of this. Then when we start this, the new child time will start. New child time will start. Then when it pops, so this child time is added to the stack. For example, when we calculate this, we pop the child time, and then we push the child time. And then when we start this, and then when we start this, it pushes the child time of this into the stack. And then when we pop the child time. But what if this? So the stack has this child time, and then you try to see the child time, but it does not have child process. So this guy must know whether it has child time, child process or not. How? So in case of this guy, push this and we push this and we pop, and then child time is this. And when we parse the next thing, it try to pop this, and somehow it needs to know whether there was child or not. How? How does it know? So from here, when you see this, we pushed. When you see this, we pop. When you see this, we push and we pop, and then we pop. So this one, the first one and the last one must know that it has child of this and this. Or if there is a child, maybe we can add some flag. So the question is, when we see this, for example, when you see this, how does, when we see this, we must know that there was a child, and then they consumed this amount of time. So probably I guess the stack can have 어렵다. When we see this, you must know that there was no child. And how? Or the other? No. So we have to maintain some kind of trace. Yeah. So this guy, what this guy needs to do is that it must put some flag, put some negative number into this guy. So what I'm think is that when start push, when and pop start exclusive time. How? And minus start minus child exclusive time, right? And set exclusive time child exclusive of its parent 2 and minus start. And yeah, vector ID yeah, I think this will work. So first we need to parse. So parse ID action time. For log for entry logs. We parse this and then now we know ID, so there must be some stack. So this stack will have ID and then child exclusive time, right? So pair ID this is ID like this, and then stat, this is call stat. So if action is, we need int ID, and then string action int time. So if action is start, what we need to do is to call stat push, then make pair, ID, and then exclusive time is 0, right? And then we also need some kind of vector where ID, no, say V, and then we make so I wonder whether this ID is from 0, 1 to no to start event will happen at the same time. No to end will happen at the same time. So there's no so this is 100. So let's just use 100. Is it okay? So what happens if the first one is 0 and then the next one is 50? I mean, is ID always incremental? So it seems that there is no rule about ID. So for example, if this is 0 and if this is 10, what should we return? I don't know. Maybe something in 0th element and then something in 9th element, and in between them everything is 0. No. So yeah, and here we don't know. Else So this is when things are complicated. We need to get top. So auto pair start context. And then assert context ID. This should be same. And then first thing is that its exclusive time is time minus maybe instead of ID it's time. Time minus, now this is useless, this is execution time, so plus 1, right? And then we need to pop, and then this is execution time, exclusive time. So int is execution time minus is child time. And then set and then if empty, not empty, we'll pick parent start context, and then this is child exclusive time. Then we need to do it with this, and then exclusive time. And since we calculate this, we have to ID exclusive time, right? So here we need to make parse. So answer free to answer, because V has a lot of empty 0 So this is what we need to do. And then private void parse the element is const string const string, then string, then string, I don't like this, but I don't like this pointer. Let's do this. What? Okay, so what's parse? So int id entry def find dot dot from 0, not id index. So id is substring 0 index -1, right? So for example, if 1, 2, then this is 0, and then index is 1, so this is correct. And then next id id +1, and then action id +1, id index1 say that this is index 2, so action is index 1, index 2. So start, let's say, and something. So this is 0, 1, 2, 3. Yeah, so start is here 0, and then length is 3. Okay, and then the last is time. Somehow these are not. This is this. So this string to be something like this, and then the last thing, time, is string I don't like substring. This is idx2 plus 1 and width. So let's say that this is 1, 2. So like this. This is 0. 1, 2. The size is 3. So 3 minus 0 plus 1. So entry dot 3 minus 0 plus 1, right? And then this is, we have to convert it. Maybe we can write some test program for this. I actually prefer this string and entry plus idx 2 plus 1 and entry dot end. I prefer this. Okay. This is looks much better. Yeah. Also, this one is much easier with this. Like begin and end is begin plus index 1, right? And also this one is string plus index 1 plus in plus 1 begin plus index 2. Yeah, much easier to understand for me. Okay, so to convert v to answer, what we need to do is we can k v dot length minus 1 v is equal to 0 v minus minus, and then int end minus 1 if v k not 0, then end equals k and then break. So we have a new vector with where is vector? Exclusive time where v plus and plus 1. Yeah. Very long, but let's run this first. 22, 28, 30, What? Invalid operand to binary expression. Oh, okay. Oh, sure. No match function a to I, s to I. Oh, f to I. Okay. S to I. Okay, wrong answer. 2, 5, 3, 4. So here, exclusive time is 2. So this is 2, 3. This is correct. And for example, this is 4. 5 minus 2. This is 5 minus 2. Make pair, not ID. Now is time. Accept it. Okay. Oh, wrong answer. Okay. What is this? Do we have a... Oh, we have... Yeah, we have an... Okay, whatever. What was n? N2. Do they have definition for n? I don't know. 1. So here, this is 1. I mean, this is 2. So, where's child? Okay. This is child execution exclusive time, right? Second. So this is 2. And this is 2. So here exclusive time is now 4. And then when you see this, 4, this is 6 minus 4 is 2, so total is 6. And then it says that total is 8. Why? Why? Time, child. Action start, make pair, time, and child execution time is 0 currently. And top, pop. then its execution time is, since this is end, time minus this start first, which is this one, plus 1. Okay, calculate its exclusive time, and then is execution time minus is start context, the second is this one. And then we're gonna add ID. We don't have information for ID. So, okay, so int ID time so in this case this is 2, so child execution time is exclusive time is 1, with execution time is 3. So we add not this one, we should add this one, right? I think so. And in case of ID, this is weird. Oh, we parse ID here. So yes. Good. It's not that fast, but it's, well, not that bad. One thing I can fix is that this one, and then we may return fee. So this one's gonna be a bit faster. Yeah. I guess this works. Okay. Not a maybe there's gotta be some easier way to using this does not have any solution, so let's see how others solve this. Python solution in C. This is for Python, straightforward with explanation, a lot of ON, stability, and then the time complexity is O of n, of course. The space complexity is what's n? O of length of log is the time complexity, and space complexity is O of n, which is this one. Yeah, this is the additional space. Stack can be maximum half of this size when it calls all the way to the top and then and all the way to the bottom. Yeah. So what? So anyways, let's see this. So here, string get line. What's get line? Oh. Get line. Or maybe yeah. Normally we might have some string tokenizer, but yeah. Anyway, so temp item log id status timestamp start push pop. So yeah, this assert is good. I like this. Then time added is what's top? Yeah, it's L end, so top must be start of this ID. So yeah, this is its execution time. So it add its execution time. And then pop. And then if there's something more, if there's its parents, and then time. This is good one. Yeah, instead of using another structure inside, it directly changes the value inside the V. Okay. Sounds cool. Sounds cool. What is this get line? Or is there any way to tokenizer? So for example, string stream tokenizer, tokenizing string, a string stream check one, get line, get line. Line. It's true tokenizer. Huh. Regular expression. What is this get line? Get line. Getline reads characters from an input stream and places them into a string. So until says so getLine input is stream, input stream, and then it read and character delimiter. CIN name. So basically what it does is that it parses carriage new line. When iStream headline what's this fail bit? Then how do they input this input? So when the bit is set, yeah, like this. Can use getLine function to split this and character function, blah blah blah. This function considers a new line character. Does not have any specific answer. So what it does is that in this case, okay, let's try. So this guy string stream so instead of this, string to integer, and this time going to directly use action, and then for the last one, time, and may not use this one. Wonder whether this works. Compile error. So the third one is character. Get line. Okay, let's finish here. Bye.